Plastic is important in everyday life, and because of its countless applications, it will continue to shape our future. Hence, it has an important role to play in achieving a circular economy. At the Institute for Technical Chemistry, the Pyrolysis group investigates the thermochemical conversion of plastic waste into products which can be fed into various processes in the petrochemical industry, such as steam crackers, fluid catalytic crackers, and even plastic manufacturing plants. Thus, the pyrolysis products can replace fossil feedstock and contribute to closing the carbon cycle. Therefore, it is important to understand how the feedstock's composition and the variation of parameters influence the oil that generates upon pyrolyzing plastic.
My research focuses on understanding the reactions in the pyrolysis of mixed thermoplastics. I investigate pyrolysis settings to enhance product quality. This will enable us to adapt the pyrolysis to the specifications of the industrial processes to which the pyrolysis oil will be fed.
A major challenge in plastic recycling is the recycling of duroplastics, such as polyurethane.
The polymer composition is individually adjusted based on the respective application, which gives rise to a broad spectrum of polyurethane materials with different characteristics that need to be recycled. Information on the pyrolysis of polyurethanes on a technical scale is therefore scarce. My research aims to identify crucial degradation mechanisms and process parameters to enable polyurethane pyrolysis.
A holistic take on pyrolysis should also include the separation of disturbing material.
Technical plastics, or engineering-grade plastics, typically contain additives such as brominated flame retardants, which give rise to a group of products in the composition of the pyrolysis oil which hinder further use of the oil. My research revolves around the separation and the degradation of bromine-containing flame retardants and the degradation of the respective plastics to which these are commonly added.
To optimize and validate the pyrolysis process, the quality of the pyrolysis products is typically evaluated. The various components are also identified. The pyrolysis group aims to lead the research on pyrolysis as an option for plastic circularity.